Good morning, good afternoon, good evening, and welcome back, everyone. I'm your host, Kev Baker, and yes, that's right, you're in the right place at the right time for another week of live shows with me, your host, right here on the Kev Baker Show on Truth Frequency Radio, www.tfrlive.com. Now remember, there's various ways to listen to the show, and just at the weekend, I helped one of my good friends from Facebook, Armand. He'd been struggling to listen to the show online, and I managed to send him a link to TuneIn Radio. Now, TuneIn Radio has got a free version and a paid version. Now, obviously, the free version works perfectly well to get your Truth Frequency Radio. They make it a little bit trickier to find, but if you just keep persevering, you will find the free option. And of course, you can come here to the home of TFR, tfrlive.com, and then also I usually try and put the shows up over on YouTube as well. So there's various ways to join in with the fun here. And this is the start of the fun month for me because July is my birthday month. And this year in particular, it's going to be extra special because my birthday lands, pardon the pun, on the 16th of July, and I was born in 1976. Now, the 16th of July in 1969 was a very, very special date indeed. It's a historic date, and I find it quite funny that there's that synchronicity between my birth date and the date that Apollo 11 set off on that infamous mission. And we're still talking about that Apollo moon landing to this day. So this month for me, it holds kind of special value because we all know I like space. And for that very reason, we are going full space for the month of July. There'll be other topics interspersed, but really, I really want to concentrate on what's going on in space. And there was huge news coming from space just last week about the fact that over 3.5 billion years ago, a burst, an energetic burst, was sent out from somewhere far, far away out in space. And for the first time ever, scientists were able to pinpoint the source of one of these what are called fast radio bursts. Now, we've spoke about F.R.Bs on the show before, and we're going to be getting deeper into this topic tonight, and even some new information for all of you out there as well. And when I seen this news breaking, and it was everywhere, folks, you know, the scientific community were going nuts about this, and rightly so. My good friend came into my mind, Brendan Drachler, and I knew that just on the horizon, Brendan was due to come back on the show. So aside from the F.R.Bs, we've got so much more to get into as well with Brendan. And for any new listeners, Brendan Drachler is an astrophysics PhD student at the Rochester Institute of Technology, working to understand how we can detect the most dense and energetic objects in our universe, black holes and neutron stars. Now, he's also working to understand the fundamental structure of black holes and how we can learn more about them. Brendan has spoken on topics ranging from our solar system to the nature of dark energy, to supernova, and many things in between. And I urge all of you to check out his podcast over at thestateoftheuniverse.com. That's thestateoftheuniverse.com. Just to give you an idea of the level of guests that Brendan gets on here, I mentioned fast radio bursts there. And Brendan, I think not once but twice, has actually spoken to the person who made the first F.R.B discovery. In fact, this dude is so important. The first F.R.B discovery is named after him. So we'll be learning more about this. Let me waste no more time, though, because Brendan is sitting patiently here. Brendan, welcome to the show, my good friend. How you doing, man?
Thanks, Kev. It's great to be here. I appreciate it. You know, from what I got out of that introduction, Kev, it sounds to me like you were born to be a NASA shill.
I think so. You know, now that people, I was kind of in two minds whether I should give away my birth date, But that's it now. It's the coup de grace. People will know that I'm definitely sold out to NASA, dude.
Yeah, it sounds like it. So you mentioned something important, Duncan Lorimer. I think there's actually, Duncan Lorimer is the man who discovered the first fast radio burst. And first off, I apologize if there's like background noise. There's like Blackhawks overhead, Kev. I don't understand. We're gonna break some news.
I was hearing it as well, man. A little bit of static, and I'm thinking, and I've been listening to your podcast today. Your audio is absolutely brilliant.
It's perfect. I don't understand what's going on out there, man. I think if we're talking NASA, we're gonna break some news.
Yep.
I think they're sending the Blackhawks in. I don't understand. They're trying to shut us down. But Duncan Lorimer, I had him on the podcast, and if the first fast radio burst ever discovered wasn't scrutinized so heavily, because this thing was scrutinized. People did not believe Duncan's data. They didn't believe his findings. They didn't believe him. They didn't believe his group. Had they actually believed it from the get-go, had the scientific community got on board with this, he may very well have won a Nobel for that discovery. The same way that the person who discovered the first pulsar won a Nobel for that discovery, which that's not completely true. Jocelyn Bell discovered the first pulsar, and due to the inherent sexism of the Nobel Prize in the 60s, she didn't win it. Her advisor won it instead, but that's a different story for a different time. The point is, this was a monumental discovery back in 2007, a monumental discovery. Fast forward to today, and you mentioned it. For the first time ever, we've been able to localize a fast radio burst to its host galaxy. Now, there's a caveat there. The caveat is that fast radio bursts tend to come in two populations, okay? One of those populations is what we call repeating FRBs. FRBs that tend to blink. They don't blink periodically like a pulsar, but they send out repeated signals, and we can observe those. And we actually have localized one of those repeaters before. We did it back in 2012, okay? And we localized it to a galaxy that was about 3 billion light years away. And it's easy to localize a fast radio burst that repeats. That's an easy thing to do because you have this cosmic signal that's continually, bleeping and on and off, and you can localize that pretty easily. What's hard to do is to localize the other population of FRBs. And the other population of FRBs are FRBs that don't blink repeatedly. They just blink once and they shut off. Okay? And this is the type of FRB that is most mysterious. It's the thing that, people have claimed it's aliens, or people have claimed it's alien spacecraft or alien technology or aliens trying to communicate, or, whatever far out idea you can come up with. People have proposed that idea to explain FRBs, but for the first time ever, we've been able to take one of these FRBs that doesn't repeat, and we've been able to figure out where it is. And it lies about 4 billion light years away in a galaxy very much like the Milky Way. And the first repeating FRB we ever found, Kev, back in 2012, the one I mentioned, that FRB was in the center of a galaxy. Okay? Now that's interesting because the FRB we found this time is not. It's in the outskirts. It's in the galactic boondocks, if you will, like where the Earth is in the Milky Way, in a place where there shouldn't be very much exciting, high-energy stuff happening. And that's where this FRB is.
Well, I imagine
that opens up tons of questions.
I was going to say that opens up a can of worms, really, because any understanding that they may have been gaining about FRBs previously, now they've kind of had this wild card thrown into the equation, right?
Yes. Well, it's interesting. It's interesting because it doesn't answer any questions. It doesn't answer any questions because it's in the galactic outskirts, okay? That means it's probably not associated with the galactic center. It's not some artifact of the supermassive black hole, which is some people have floated ideas out there like that. When we found the first FRB, when we localized the very first one, it was in the galactic center of a galaxy. It was very near the galactic center, and we thought, some people, and I say we like it's consensus. It's not a consensus. It's a very open question in the community. Some people thought that maybe there was some role being played by the supermassive black hole at the center of that galaxy that's causing these outbursts of radio waves, these FRBs. Now we find one far, far away from the galactic center. So it helps us a little bit because it helps us, throw some theories away, but it doesn't eliminate very many. Because it could still be caused by a neutron star. It could be caused by a tiny black hole. Hey, it doesn't even eliminate the possibility of aliens. Because where would aliens be? Well, they would probably be out where we are. So, it almost introduces more questions than it answers.
So for myself and the listeners out there, I mean, give us the kind of F.R.B. 101. I mean, how do they detect these things? And what's the most commonly held theory as to what's producing them then? I know you went through a couple of things there, but how do we detect them? What are they? And what's the commonly held idea so far?
This is a good question. How do we detect them has changed over time. The first one ever was detected in data that was meant to be looking for pulsars. Duncan Lorimer, he had a data set, and the data set was from radio telescopes, hence the name Fast Radio Burst, and it was looking for pulsars. And if you don't know what a pulsar is a neutron star that spins incredibly fast. We're talking, once every millisecond or so, okay? So it spins incredibly, incredibly fast, and as it spins, it's like a cosmic lighthouse, and it lets out radio waves on every spin, on every orbit, bursting radio waves out. And Duncan is a researcher looking at pulsars. Okay, Kev, these Blackhawks might go away soon. I don't know what's happening here. There might be I don't know what's going on. We have the FBI. I don't understand. I don't get it.
I think it's because we're talking about these F.R.Bs, and they know that we've got big F.R.B. news to come. That's what it is, dude.
Yeah, I don't know. Maybe, I'm not sure. But Duncan was looking at this archival data. It's old data, and one of his undergraduate students actually was looking at it, and they were like, "Wait a minute, there's this real sharp peak here, but it doesn't happen again. It's not a pulsar. It seems to just be a blip in the radar, because you look at radio data, and it's literally just like scribbles on a piece of paper. And pulsars, they would have very, regular blips on that piece of paper.
Almost look like a heartbeat, I take it.
Yes, sort of like an EKG type of thing. Of course, it's very noisy, and you have to subtract the noise and get to the signal. But the point is very similar. Now, the F.R.B. didn't have that. It was just a giant spike. And his group, Duncan Lorimer's group, said, "What could this be? This cannot be explained." They went through. They tried to find systematic errors. They tried to find why it could be there. They tried to find if the telescope had a mistake. They couldn't find anything wrong with the data. It seemed to be perfect, but yet there was this blip that could not be explained. Okay, and it turns out that the blip is a fast radio burst, the very first one ever found. And it was found accidentally. No one was looking for it. No one was trying to find it. No one even had an idea that an F.R.B. was a thing. Okay? And it's actually interesting. A study was published this year that went back and looked at that old data that Duncan had found the first F.R.B. in, and it actually used machine learning algorithms to sift through that data. And what they found is that there's actually a second F.R.B. in that original data set.
We've spoke about this previously, Brendan, how maybe AI could really come in and look at the data that's already there and find things, little nuggets like that were previously missed. And, how painful it must be for Duncan, because that might have been enough, right, to maybe solidify that Nobel Prize, because people would have taken this seriously a lot sooner, right?
Yes, that is very possible. Duncan's not the type of person to be like, man, I should have won a Nobel Prize.
No, he's a very humble man from what I could hear on. Yeah.
Incredibly humble. But yeah, it was a monumental discovery, and it opened up a whole new field. And it took him a while to convince people that this was a real phenomenon that was being observed, because most people had doubted him. He couldn't get funding to build a telescope devoted to trying to find these things because people didn't believe that they were a real thing. So this is actually an important lesson for the listeners who doubt science or doubt the scientific method. Sometimes real scientists come along and they find something, and through perseverance and through, continuously proving their theoretical framework, they can begin to take something that is initially denied and make it accepted and develop it in a sort of way. And I advise anyone out there who has an idea that maybe is a fringe idea to do that exact same thing. To say, okay, listen, I have faith in this idea. Here's why I have faith in this idea. I have data that supports this idea, and try to handle it in a very scientific manner and test your framework, test your theoretical framework, and try to push it all the way through to the point where you can start to open up other people's eyes and say, look, this is a real thing. Because that's exactly how F.R.B. If Duncan was not persistent, it might very well be the case that we still don't have observations of F.R.Bs, because today we actually have telescopes that are looking for them, that are actually out there trying to find F.R.Bs, which are just little blips of radio waves in the night sky. And you know, one of the things that I talked with Duncan about, this isn't public knowledge, Kev, so I'm very happy to mention it on your show, is this is not a closely held secret, but it's certainly not publicized. The CHIME radio telescope, we talked about CHIME before, and some of the other new radio telescopes coming online, they had detected 13 new F.R.Bs in the beginning of this year. We talked about this in like January, you and I, Kev, like a long time ago. And it was monumental. We were like, man, 13 new F.R.Bs. That like doubled the number of known F.R.Bs. Well, I can say here today that the new era of telescopes, although it hasn't been released publicly yet, have found 1,000 F.R.Bs. And they are currently sifting through that data and making sure that all of it is sound and complete before they publish those results. But nevertheless, sitting in an archive somewhere, we have literally thousands of F.R.B. observations. That's incredible.
That's huge. That really is huge, dude.
Yes, and now to get to the second part of your question, what are these things? Well, that's an interesting question. And I can confidently say that we don't know. There's people who say aliens. There's people who say some kind of black hole phenomena. The most accepted theory tends to be in relation to what are called magnetars, which are really highly magnetized pulsars. What we don't know is how magnetars even come into existence. So when you have a supernova explosion, or you know, when you have two stars, like a white dwarf, say, accrete matter onto it, it explodes in this giant supernova, and the remnant is a neutron star. Now, what the difference is between a neutron star and a magnetar is that magnetars are neutron stars, but they have really, really high magnetic fields, and they seem to be a lot more rare. Neutron stars are found way more often than magnetars are found. We don't understand why. We don't understand what could result in the production of a neutron star with such extreme magnetic field behavior that literally constrains. So even though magnetars are spinning really fast, Kev, you don't have that pulsar-like behavior because the magnetic fields are literally constraining the pulses from coming out. So you can't observe them the way you'd observe a pulsar, but they do let out little blips every now and again, similar to what we see in fast radio bursts. But we don't know. We don't know what process it is in the magnetar that could possibly be producing the F.R.Bs that we're seeing.
Now, there'll be a lot of the listeners, especially to this show, myself included, over the time we've heard about these fast radio bursts. Like you've said, aliens, we can't rule them out. But the way I think about that is I flip it around, Brendan, and I'm going to ask you, because how would we, as a civilization, generate something akin to a fast radio burst? Can we do it from our planet? Is it something that we could do and send out there into the cosmos? And I ask that because that's what the aliens would have to be doing if we're assuming that they're the ones responsible for this. So is there any way that we would be able to replicate what we're picking up here?
It's an excellent question. I'm going to answer, but first I want to make a point because I wanted to make this point. We've talked about F.R.Bs in relation to aliens before.
Yeah.
Okay. One of the interesting things about this new news that we just discussed, this thousands of F.R.Bs, is that it sort of rules out the alien idea.
Yeah.
Unless there's tons of alien civilizations all over the entire night sky, which I suppose is possible. But then, of course, you have to, sort of believe in the fact that somehow they all develop the exact same technology that can produce the exact same signals. I don't know. So this idea sort of rules out the idea of alien civilizations being the producer of F.R.Bs. There are some people still who try to fit the data to their conclusion, which is the aliens. But to answer your question, I don't think so. Not as it stands right now. And the reason is that humans are really good at producing continuous radio emission. We're not necessarily all that great at producing what we would see in an F.R.B. We produce continuous radio emission every day in our satellites, in our cell phones. We produce radio waves that flutter out into interstellar space and will continue, out into space for years and years and years to come for some civilization to eventually pick up. One of the very first things that we've ever broadcast over the radio was one of the very early speeches that Hitler gave, actually, which is, an interesting ethical dilemmas. We're passing these radio waves out there. What if an alien civilization picks us up and starts hearing World War II jargon? They're going to think that this is a really, really bad place to be here on planet Earth. Of course, not knowing that it's gotten much better over the years. So I don't think that we would be very good at producing just a blip on the radar like this, a really high energy blip of radio waves. We are good at just secreting constant radio emission, though. That's one thing we do. We're literally like just screaming out into interstellar space. We're just screaming.
This is why I like speaking to you, because my confirmation bias would side towards, oh, it's going to be something alien here. But I like to try and keep myself more logical. And speaking to people like yourself with that scientific kind of grounding and background, that's why I really appreciate it. And I'm sure the audience appreciate this kind of take on things as well. Because, yeah, I'll come back and I'll speculate about the aliens and the sci-fi stuff. But we have to really mix it. We have to have that balance with what is actually science as well, you know?
Yeah, well, one of the weird things is it could be aliens.
It could be aliens, exactly.
You have to reserve that possibility. Do you remember the recent? This is off topic, but there was a recent asteroid that went through.
Oh yes,
the solar system. Oumuamua, is it? Oumuamua, something like that.
The messenger.
Weird name.
Yeah, it's Hawaiian for messenger, and they did say at the start. I think it was somebody called F.R.B from Harvard. He was basically saying this could be an alien probe, and I think it's back in the news today, Brendan. Right?
I don't know if it's back in the news.
Yeah,
I haven't kept up with it. I've tried to get a few people on to talk about it, but no one's...
The latest study says that although they haven't fully ruled out the alien hypothesis, it's more and more likely that it isn't that. But at the same time, they still are no closer to telling us where it formed, how it got here, blah, blah, blah.
But the reason I bring that up is because I want to illustrate something about the scientific community. If you look at papers published that analyze that, and you look in their conclusions, they will say, we think that it is this mechanism that resulted in us observing Oumuamua, but it's very possible. It's not very possible, but there's other possibilities, and they'll list the other possibilities, and they will mention it's possible that it's some alien spacecraft. That is a legitimate concern. Now, of course, there's no real way to test that. How do you test that hypothesis? That's a tough hypothesis to test outside of short of building a spacecraft to go try to catch it, which isn't going to happen. But the idea of aliens is floated around a lot more often than not. I've mentioned to you the LGM-1 debacle before. The very first pulsar ever discovered was nicknamed LGM-1, which stood for Little Green Men 1, because the researchers at the time literally had no other explanation than it's aliens, I guess. So this is an idea that's floated around more often than you'd think. But of course, I
think as a scientist, I would be quite excited at the kind of thought that something might be alien, something that's totally unexplained, something we've never seen before. I think that would be exciting for a scientist.
Oh, it's definitely exciting for a human.
Yeah.
For anyone, just the prospect that you're not alone in the universe, because the fact that if you are alone in the universe, I forget who did this quote, but I'll rip it off. And I would love to credit them, but unfortunately I just don't remember who it is. But it's a pretty popular author, I think. It goes something along the lines of, being alone in the universe is terrifying, and not being alone in the universe is equally terrifying. Both, essentially both options scare the shit out of you. If you're completely alone, well, goddamn, what's the point of life? Sometimes I look out my office window and I just I can literally induce a panic attack in myself by just thinking about the vastness of space. And to think that in all of that, it's just us on a little pale blue dot, a little meek ball that realistically doesn't mean anything. And if the universe wanted to, they could expunge us tomorrow. That's scary. And then thinking that we're not alone, and thinking that some other civilization has the technology to expunge us tomorrow. That's equally terrifying.
Yeah, I mean, I like to sometimes watch the Higgs field, and they've got a 3D kind of version, HD. You can fly through all the galaxies, and just watching a couple of minutes of that, it's mind-boggling. It's hard to even conceptualize anything near what the size of the universe is, Brendan.
You can't. I don't think you can conceptualize it.
No.
Tomorrow I'm talking to tomorrow on my show, I'm interviewing the Canadian Space Agency's ambassador for the James Webb Space Telescope. And one of the things that she studies is the structure of the universe, the very structure of large scale groups of galaxies, galaxy clusters. And I want to, mention that to her, how do you conceptualize this? To think that there's billions of galaxies with billions of stars in each of them, it literally just blows my mind.
Absolutely, dude. Now, before we go to the break, let people know where they can listen to your podcast, man.
Yes, thestateoftheuniverse.com. Go check it out. We're available everywhere. Everywhere that this show is available, we're probably available there too. We just recently got added to iHeartRadio. I'll probably get kicked off of there. I tend to curse a lot. We're on
Well,
iTunes.
hold
We're
that
on
thought. We'll be
Google
back
Play.
after the break. Don't go anywhere, folks. Brendan Drachler is my very special guest today, and we are getting spaced out. Not literally, folks. Brendan is an astrophysics PhD student from the Rochester Institute of Technology. He's here with us today. He's also the host of a brilliant podcast that I want you to check out, The State of the Universe, and that's thestateoftheuniverse.com. So, Brendan, we were having a good laugh during the break. We were talking about those pesky Blackhawks, how they have left you alone now. Hopefully, we'll be Hopefully, we'll be left to do the show in peace. But that's only because we're going to take on our other role now of shilling for NASA, because NASA are all over the news, dude. Lots of exciting stuff happening in space. And in fact,
get my NASA badge out.
I think you sent me a story, right? And it was actually talking about how we could start going to the ISS. What's going on, man?
Yeah, so last week on the show, I had a ISS flight operator, and he's actually a good friend of mine, and he's a ISS flight operator now, an official NASA shill. He works for NASA down in Houston, Texas at Johnson Space Center. And he was talking to me about this. He's talking to me in this episode 51 of my show, maybe 52. I don't remember what number we're on.
51.
It's getting too high. We're getting too high. But anyway.
51, Nate Stewart.
Yes, Nate Stewart. He's a brilliant man. And he was talking to me about NASA because Johnson Space Center very much is like the hub for human spaceflight. It always has been. It's, the speech, the Go to the Moon speech was made at Rice University where Nate went and got his master's degree and before he went to work at NASA. So the Houston area and the Houston Astros is the baseball team there. Most people don't know that. That's named after astronauts, Houston astronauts. But anyway, he's very ingrained into this world. And he was talking to me about some news that was going to be announced, and that's that NASA is now offering, they're allocating about 5% of their utilization of space to private citizens, people who aren't necessarily invested in science. They're not going to do research, but they can literally just buy themselves a ticket to the ISS. And some prices that he gave me, I think these prices are now, I don't think we're breaking any news here. I think the prices have actually officially been announced now, but he gave me these prices. This is what NASA will charge you to be a private citizen to go to the ISS. They will charge you $22,000 per night that you spend there, and that gets you everything you need. It gets you food, it gets you water, it gets you a bed, it gets you life support, it gets you all that stuff. Okay, if you want to bring stuff with you, which of course you do, you can't go naked, you have to bring cargo. It's going to cost you about $3,000 per kilogram, okay, to get it there, and then $3,000 per kilogram to get it back. So that adds up, Kev. You're talking about charging millions of dollars for a week's stay, okay? It will cost a lot of money for a private citizen to go there. You could, because you have all these add-ons, like if you want to use the internet, data is going to cost you $50 per gigabyte, and the price just keeps going up and up and up and up and up and up. And of course, you're not going there empty-handed. You're going to bring stuff with you, so the $3,000 per kilogram is going to add up very quickly. For the U.S. listeners, a kilogram, 2.2 pounds. Okay, if you bring a half gallon of milk with you, you'll be paying $3,000 to get it there, and if you bring it back, you're going to be paying, if you throw it away on board, you're going to be paying $3,000 per kilogram to throw it away, because you have to pay whether or not you bring it back or if you throw it away.
Wow.
The point is, NASA is moving in this direction, and they're moving quickly.
So how are they proposing said astronauts, ISS-onauts get there? Are they going to be flying it? Is it going to be SpaceX? Or is it going to be Bigelow, because they're entering the race as well, aren't they?
Yes, Bigelow Aerospace is also selling tickets to the ISS, and they are selling you a couple months stay, like 1 to 2 months, for $52 million a piece.
$52 million? Now, oh, dude, I'll get us one each. It's okay.
Yeah,
sure.
Man. I would love it. Let's
Yeah,
do it.
take a
Yeah.
suitcase. It's okay. I'll
If we could
splash out.
we could be round Earth shills too once we see the curvature.
Why not, dude? Why not?
Yeah. So I'd love it. I would honestly, I hope in my lifetime, in all seriousness, that I am in a situation where the cost of space commerce has driven the price down so that normal people can do space tourism, say like 5 grand, 5,000 American dollars. You go to the ISS for 2 days. I would totally spend $5,000 on that.
You
I
look
mean,
at the kind of price difference between the way NASA used to do it and even SpaceX, what they've got it down to now. And I only imagine SpaceX will make it cheaper and cheaper as time goes on, right?
yes, well, competition will. So, SpaceX isn't the only person lobbying for, you have Blue Origin and you have Boeing and you have all of these companies that are, trying to drive costs down as cheap as possible so that they could get the big NASA contracts. And they're also trying to work as efficiently as possible. It's the beautiful thing about capitalism is it's going to drive the price down over time as you have this natural influx of competition in the market. And it's going to do great things for consumers who want to, buy tickets or involve themselves in some way in this
I find
commercial industry.
I find Bigelow, that's quite interesting because they've been in the news recently, and it all kind of started back in December 2017, because that's when the Pentagon or people came out and started talking about that Pentagon program called ATIP, Advanced Aviation Threat Identity Program. And it turned out that Harry Reid, the senator involved, it was 22 million, I think, over 5 years, which isn't much when you think about it, Brendan. But that
No,
went
it's not.
to Bigelow Aerospace. So I find it interesting that they're the ones now talking about taking, well, for 52 million bucks. I don't know how many people they'll be taking, but at least they're trying to get in on the game here.
Yeah, it seems interesting that they're charging so much because if you compare that to the NASA price, the price is pretty low. But Nate, the ISS flight operator, told me that NASA expects there to be essentially bargaining, or not bargaining, that's not the word, but what is that where people hold up a sign and they yell a number? What the
An
hell
auction.
is that? Auctioning.
Yeah.
Yes. They expect people to try to essentially drive that price up. So because they're only doing 5% utilization, they can't just send an unlimited number of people to the ISS. The number of people going on any given year will be capped. And so because it's capped, you will have people driving the price up saying, wait, Bob is willing to give you 60K, but listen, I'll give you $80,000 per night. And then Kev Baker comes along and he says, wait, I'll give you $100,000 per night because my show's taken off. So I have all the podcast money. And then Brendan comes along and says, wait, Kev, my show's getting even bigger than yours. I'll do 120, and etc. So they expect the price to slowly be driven up.
Yeah, that's kind of cool. And right, I could be wrong about this, and I know it's very minuscule, but if I'm on the ISS and you're down here, I'm going to age just slightly slower than you, won't I, over time?
Yeah, but it won't be
yeah, it's minuscule. I would have to spend like
yes.
a bajillion years up there for it to mean anything, which is impossible in this current spacesuit I've got, right?
Correct. Yeah. One of the most interesting things to look at is the twin experiment that NASA did.
Yeah, man.
With the Kellys. Yeah, that's an interesting thing because it essentially just taught us about the real health effects of spaceflight. Like it's just, man, it's not a good thing to do to the human body for long periods of time. And we need to get those ironed out before we send anyone off to Mars. And that's something we're working on right now. But yeah, this is an interesting change of pace, Kev. When you're talking about actually NASA coming out and saying, listen, we are going to put 5% of our resources into just getting ordinary people to space. Now, of course, it will only benefit, or it will only involve like wealthy people or wealthy companies at first. But I do believe that it will change over time. And I do believe that it will become more affordable.
No, absolutely. And of course, this isn't the only thing NASA are talking about, because just the other day, they announced something really, really cool. And the last time we were on the show, I think we were talking about the potential for life in Europa and things like that if you were to get down beneath the ice. And they're not going to Europa, but they're going to Titan. Talk to us about this, Brendan, because again, when I heard about this, I'm thinking Brendan's going to be loving this, because you were saying the moon's interesting, but let's get further afield, right?
Yes, I am a proponent of, well, I should say I'm a proponent of making a plan and sticking to it. So if the plan is to get to the moon by 2024, Let's do it. I'm sick of flip-flopping on this thing. But yes, Nate told me that the feeling within NASA, and I feel this too, is that NASA has become too much of an aerospace company or an aerospace industry, and that's not what they are. That's not what they were made to do. They were made to do science. They were made to do science that requires the utilization of resources in space. They were not made to fly people to and from the ISS for 20 years, which is what they've been doing. They want to offload some of their resources, which is what we were just talking about, to private companies, to private people, and they want to get back in the game of science. They want to start doing real science where they explore the solar system and the universe, and this is the start of that. We are going to Titan. We're sending a quadcopter to Titan, and that is incredibly exciting. We've been to Titan before. It is arguably the most interesting place in the entire solar system. We went there with the Cassini spacecraft, and Cassini was like maybe the most successful, maybe the most interesting spacecraft in the history of our exploration of the outer solar system. I mean, this thing did so much. It analyzed Enceladus for the first time. Enceladus is a moon of Saturn, and we now know that Enceladus has these cryovolcanoes on its southern side, and these cryovolcanoes blast out water vapor and other molecules, and Cassini flew through a plume of them and identified that there's actually complex organic compounds in that water. So you have a liquid ocean underneath the ice of Enceladus, and not only do you have a liquid ocean, but Cassini was able to show us that inside of that liquid ocean, there's complex organic compounds.
And if that's in our own solar system, dude, we were talking about these millions of galaxies and millions of stars and things like that, billions and trillions. I mean, that really kind of ups the potential for various life forms, microbial. I'm not going full woo on you, but it really does. I mean, it used to be a question, is there any life out there? Seems to be, it's quite common, actually.
You don't have to go full woo on me. I'm with you on this. I think that the planetary scientists' idea of habitable life is way too short-sighted. I think that life, and we've talked about like extremophiles here before, I think that life is way more adaptable than people think, or than typical, theory holds. I think that you could probably have life thriving in some very extreme conditions. And it's possible that liquid oceans on some of these moons is one of them. But, back to Titan, Cassini also explored Titan, and it actually sent a probe down onto Titan, the Huygens probe. I can never say
that's
the name.
it. Yeah, that's close as, yeah.
It's a weird word.
It's Dutch or German or something. Huygens sounds good to me.
I'll show you. We don't. This probe, unfortunately, was the spacecraft. The Cassini spacecraft was launched in 1997. So our technology, when it comes, how crazy is it that it's 2019? Wow, that's nuts to me.
I know.
I feel old, and I'm only 24. So
wait till you get to 42.
So we launched the Cassini spacecraft in 97, and our camera technology was pretty poor at the time. All of our technology was pretty poor at the time. I mean, compared to now, I say poor. At the time, that stuff was cutting edge. They had VCRs. They had all sorts. They had dial-up internet. But compare it today, and it's rather primitive. So I'll send you a picture, Kev. This is one of the few really good pictures that we have of the surface of Titan, but I'll ask you to open it, and there's a few things that I think are worth discussing on this picture, a few things that are very interesting about this picture. So one of the things you can see in the picture, let me know when you have it open.
I've got it there, yeah.
Okay. One of the things you can see in the picture is that the stones, we'll call them that for now, those stones look kind of smooth. They look smooth, almost like the types of things you'd see in a riverbed here on Earth.
Very.
And also in the distance, in the distance you can see a lot of those. We're calling them stones for now, but we'll flip the script on that in a minute. You can see a lot of them in the distance, and you can see some in the foreground, but you also see a patch where there doesn't seem to be any. Okay, and along that patch you see these weird like striations of material that seems to come off of these little stones, these little pebbles. Well, Titan is really cold. Okay, it's like negative 170 degrees Fahrenheit. Negative 170 degrees Celsius. It doesn't matter. It's cold. The point is it's cold. It's much, much colder than flowing water could exist at. Those boulders you see, those rocks, are actually likely ice. That's likely water ice. Okay, and it's so cold there that they literally just form almost like rocks. And we
Wow.
believe that there is actually lakes, and believe isn't even the word anymore because we've actually detected them. There is lakes and rivers and flowing hydrocarbons, methane, ethane, things of that nature, like natural gas. There's more natural gas on the surface of Titan than 300 times the amount of natural gas we have here on Earth. So naturally, the U.S. government's interested, right? They're looking to get there tomorrow, but it's an incredibly interesting place. It's the only place that we know of in the entire solar system where you have liquid that flows. It doesn't matter that it's not water. It doesn't matter that it's really cold. The point is you have liquid that flows, and you also have one of the most dense atmospheres of any object of any terrestrial object, any object with a ground that you could stand on. You know, this atmosphere is 1.5 times the density of Earth's atmosphere. And Titan is pretty big. It's like 1.5 times the radius of the moon. So put all that together, and you have a very, very interesting place. And we're looking to send a quadcopter there.
Yeah, I mean, I'm just watching this here, and if people are watching the kind of replay on YouTube, this is some of the coolest kind of tech out there. I mean, this is absolutely amazing. They're going to drop this kind of quadcopter in and out of the atmosphere, aren't they? Are they going to be taking samples back, Brendan?
No, there will be no sample return, but there will be a lot of analysis. So this quadcopter will land. It'll land like you're seeing in the video right now. It'll land on the surface. It'll do measurements for about 16-ish days. It'll sit there for 2 weeks, essentially 2 Earth weeks, and then it'll jump. It'll bounce. It'll jump to and fly to a new location. And the good thing about Titan is the atmosphere is really dense, so it's easy to fly things. We have a problem with flying things on, say, Mars, and we can talk about that in a little bit because we plan on doing a very similar thing with Mars, sending a helicopter. But, you know, Titan is easy to fly stuff on. It's almost very similar to the Earth.
Now, it's not somewhere that we would ever be able to thrive as humans, though, because I remember watching a film recently on Netflix, and it's called Titan. And basically, there's a problem with the Earth. You know, the typical kind of dystopian scenario you get. We need to think about moving out, going elsewhere. And what they do is they decide on Titan, and they have to genetically modify, you know, humans as we are to be able to function in that atmosphere. Now, is it high in nitrogen, stuff like that? Would I be right in saying that? Because they basically, in the film, they explain how they have to change even the way that we breathe and stuff like that, you know?
Right. It's about 95% nitrogen.
Wow.
It's an incredibly interesting place because, you know, most models of the early Earth indicate that Titan might very well be a good model of what the early Earth looked like.
Well, that's why I was reading. Yeah, that's why they were quite excited, because it's almost, the way I read it anyway, or the way it came across to me, was it's almost like a time capsule or going back in a time machine, because we're seeing how the Earth, roughly how it might have been billions of years ago.
Yes, and by analyzing the density of Titan implies that there's probably some liquid water underneath the ocean or underneath the surface. There's probably some liquid water, salty water underneath the surface of Titan, buried deep below, which we tend to see is a common theme on most moons of the outer solar system. The moons around Jupiter, the moons around Saturn. So this place might literally be like a very early Earth. Now, of course, it's very different in the sense that it is it gets about 1% of the sunlight out there that the Earth would get here. You know, so it's like in no way is it gonna.
It's like Scotland then, Brendan.
Yes. Well, let's not get ahead of ourselves. Scotland's definitely worse. Right?
You're probably right there, dude.
Yeah. So it's a very interesting place. I'm excited for NASA to finally be getting back in the world of science. Now, of course, we're gonna have to wait until 2034 until this thing actually gets there, touches down, and begins sending us results. But nevertheless, we're moving in that direction where we can start doing science again, and we don't have to worry about just shipping our astronauts off to Russia to fly them to the ISS and not getting any monumental science done for long periods of time.
Now, Mars, we were going to talk about that as well, and there was methane detected on Mars just recently, and also there was an alleged kind of bright flash of light that was picked up by one of the rovers as well. Interesting times again in space, and this time Mars, we're going back there, we're going to do more. I mean, what's your take on the methane that was detected? For me, that kind of indicates maybe something thawing out from the past, or perhaps some microbial action. I don't know. What do you make of the methane discovery? And then talk to us about going back there with this kind of helicopter.
Well, the methane is interesting simply because it implies that there's some active things happening on Mars. You know, it's not a dead planet. It's active, and it's active in its own way. And I'm very interested to get back there and to analyze in more detail the surface, the subsurface, the ice caps, the entire planet of Mars. I think it's a very interesting. It's a desolate place, but it's interesting. And you know, I'm incredibly interested in actually getting a sample return mission. That's one of the things that I care most about Mars. My interest in Mars is dwindling a little bit because I'm to the point where I want to see people there. You know, and I know that that's decades away, but you know, it's almost like, man, let's stop sending rovers. Let's get people. But of course, you can't do that. You have to move slowly because you don't want to sacrifice people. You don't want to just sacrifice people for the sake of science. That's not necessary. That's historically maybe that has happened, but I wouldn't like to see that happen again. So, you know, the methane is interesting because it's things like that, discoveries like that, that renew the interest in Mars and say, oh, wait a minute, this place isn't so desolate after all. There's stuff happening here. And, you know, it's important to have things, reminders like that. Because in the case of Pluto, you know, when we sent New Horizons to Pluto, most people thought it was going to be a pretty desolate, boring, barren wasteland. And it turned out to be one of the most geologically interesting places in the solar system. So I think that if we are able to study Mars to that same degree, to actually analyze the surface in incredible depth and get return missions where we can actually analyze the samples using the technology we have back here on Earth, that will be an interesting change in my interest in Mars. So we do plan on going back. We plan on going back to Mars as early as 2021. We'll be back there. We'll be back there with another rover. And what's most important about this particular rover is that it will collect samples that will be used for a later return, because eventually we'll send an orbiter to Mars, and that orbiter will be accompanied by technology that will allow us to retrieve the sample from the Mars rover and ship it back to Earth. And that is the most exciting thing going on with Mars. And of course, the helicopter. Do we have time before the break to discuss the Martian helicopter?
Oh, definitely, dude. This is exciting stuff. I've got the story up here as well, yeah.
The Martian helicopter is one of the more interesting. Mars is a tough place to make a helicopter work. A really tough place because the atmosphere is only about 1% as dense as the atmosphere here on Earth. Okay. Now, how does a helicopter here on Earth work? Well, it works mainly because we have a dense atmosphere. Okay. You have a dense atmosphere, a lot of fluid to push through. And so you can make a helicopter rise and fall or an airplane rise and fall. When you lack that ability, and also add in the fact that it's really, really cold, you create this environment that it's really hard to make things fly, especially helicopters. And so they're necessary, though. It's necessary that if you want to get around the planet fast, that you devise some way to fly, because driving, even here on Earth, driving is not an efficient mode of travel. How fast do you think the Mars rover goes, Kev?
3 miles per hour, maybe?
Okay. Lower.
Whoa.
Much lower, in fact.
Mile per hour.
Even lower than that.
Wow.
It is about 1/10 of a mile per hour is how fast it goes.
Damn,
okay?
That's like my mum driving, dude.
Yes, exactly. Yeah, you walk 30 times faster than it.
Oh, that's crazy. You see, you don't think that when you're actually... I mean, I don't even think I've even thought about how fast it goes.
Yes, and there's a very important reason that it goes slow. There's a very important reason that it goes very slow, and the reason is that it takes a long time to communicate with it. So if you need to navigate it, if you need to tell it, no, don't drive that way, you're going to drive over a cliff, or don't drive that way, you're going to hit a rock, this is sensitive technology. It has to go slow in order for us to be able to communicate effectively with it, because it takes anywhere between 3.5 minutes if Mars is the closest to us it ever gets, or up to 24 minutes if Mars is the furthest away that it gets from the Earth. So the communication time changes, and you don't want to be communicating with. Imagine if it took you a 24-minute response time when you're driving. Now, there are people in New York that have a 24-minute response time when they're driving, and I hate those people.
So does that mean it's going to have a 48-minute delay until you see your actions actually materializing? Because it's going to take 24 minutes for the signal to get back to you.
The 24 minutes is a round trip.
Cool. Got you. Right, cool.
So either way, but it doesn't matter.
Yeah.
It doesn't matter because, that's insane.
Yeah.
If you tell it to turn right, it's going to take, tens of minutes for it to listen to you.
For people out there, imagine having a telephone call where you're speaking to somebody and you have to wait 24 minutes to get a reply back. I mean, that's no conversation. That's not communications per se,
That's frustrating.
Yeah.
It's incredibly. And so one of the ways that we plan to address this is by using a helicopter. And the helicopter that we're sending there now will be attached to the bottom of the rover. And when the rover lands, the helicopter will demount, if you will, and the rover will drive away a safe distance so that in case the helicopter crashes, it doesn't crash into the rover. Boy, imagine that. Imagine NASA spends, millions of dollars sending a rover and a helicopter there, and the helicopter crashes and plummets into the rover and the whole entire thing. It's horrible. Setbacks like that ruin decades of scientific advancement.
That's what I'd like to see if we're going to send rovers. I mean, surely with our capabilities now technologically, we could basically send some kind of remote science lab. I mean, I know some of the rovers do some basic testing. We'll find out more about this after the break with Brendan Drachler, thisstateoftheuniverse.com. Hour number 2 already, ladies and gentlemen, on today's Kev Baker show with our special guest, and he's a monthly guest, and I'm so proud to have him here once a month, especially in these times, because there's just more and more and more to talk about when it comes to all things space-related. Brendan Drachler is on the show with us here, and if you want to check out his podcast, and I insist that you do, head on over to This State of the Universe. That's thestateoftheuniverse.com. You can get all the audio files on there, 51 or 52 episodes, I believe. And Brendan was saying earlier, he's got somebody from the James Webb Telescope team coming on this week. Brilliant lineup of guests there. And I'm looking at the chat room, it's filling up nicely in there. I'm pretty sure, although we have flat Earth shows on the network here, Brendan, I don't think we'll be getting too many of the flat Earth listeners today. And if we do, they really will be thinking we are bought and paid NASA shills. So, yeah, our paycheck is in the post.
I'll have to contact my my ISS flight coordinator friend and tell him to make NASA get on that, because I'm out here shilling their stuff all the time, and I have never received payment.
See, I'm doing this whole shilling thing wrong as well. I got told to get paid by George Soros. But somebody must have forgot to tell Soros, because he never ever sends me any money, dude. And it's pretty crap, this whole shilling business,
Yeah, I've been working for free for too long. So I'm ready to go flat Earth, anti-NASA, in a couple of weeks here if I don't start getting some money.
That's it, dude. That's it. And, tomorrow night I'm actually going to be joined by a guest that you recommended to the show. And that is Dr. David Warmflash. He is going to be coming onto the show here. Probably the coolest name that I've ever had on the show. And I want to thank you, Brendan, for basically recommending him, because I've been taking a quick look at his work. I'm going to start really diving into it between this show and tomorrow. But what an amazing character, and what an amazing wealth of knowledge when it comes to the moon.
Yeah, he is his name. I don't understand how it's not fake. I don't get it. David Warmflash?
Yeah, it's brilliant.
It doesn't even seem. I don't know.
It sounds like he should be.
It's like he
should be hanging out with Iron Man.
Yeah, he should have been a cosmologist. Is what he should have been.
Definitely, dude. Cool name.
Fit.
But you've had him on your show, so is that one for the listeners to look forward to tomorrow?
Yes, his book. He recently wrote a book, An Illustrated History of the Moon, and I would. Now, I should, here I go shilling again. I should get paid to say it. That really is it's a great introduction into the history of the moon for literally, if you have kids who are interested in space, that is a kid-friendly, it's just like 100 short moments that he goes through, like 100 moments in the history of the moon, and each moment only takes one page. So it's like someone that, I did a giveaway of the book on my show, and I gave the book away to several listeners. When that episode aired, I made them jump through a few hoops for me, and I gave out free books to all the listeners. And someone said to me, "It's the perfect bathroom book." That's the compliment that someone said to me, because it is. You just read like 1 or 2 pages here, set it down, and pick it back up again. And it's like a fact a day type of thing. Like you invest 5 minutes into it, and you learn a bunch. It truly is a good book, and you should tell him when he comes on tomorrow, Kev. I expect payment for this advertisement. Okay, so tell him he has my address. I expect a check in the mail.
Absolutely, dude. I will be doing that. I really will. So before the break, we were talking about NASA. We were talking about Titan. We were talking about Mars. Where did we leave off before the break?
The helicopter.
Yeah, the helicopter, man.
Martian helicopter. Yes. This is a very, 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 very interesting thing. It is a test. It is merely a test. It will only fly a few times. It will only fly a few times on the Martian surface. It won't fly for very, very far. And it will only fly just a few times. It won't do any crazy maneuvers. They are just testing it. They're testing whether or not they can achieve autonomous flight, whether or not this thing can navigate itself without crashing into a ravine or something. And if it works, it opens up so many possibilities for exploration, not just of NASA, but of different places too. I would love to see us send some form of helicopter-like thing to Venus. Venus has its own bag of tricks that we have to learn to fight. But this test.
I've never really spoke much about Venus on the show, Brendan. And if you could give us like a quick crash course in Venus, that'd be cool, man. Because it's not one of the more talked about kind of planets,
No, and it is kind of really interesting. It's literally a sister Earth. It's a sister Earth that underwent a catastrophic greenhouse effect and has become this insanely. The entire surface of Venus is like essentially the same temperature, which is weird for us to think about here on the Earth, where we think about the equator being beautiful and the poles being super cold. Venus has such a dense atmosphere. It has undergone such a greenhouse effect that literally the entire surface is just completely uniform in its temperature.
Now, I've got pictures of Venus up here. I'm not sure if you can see them.
Yes, I can.
There's some that look like it's a red hot ember, and then there's other ones that looks like it's got cloud systems and almost like a blue, as if it's an ocean. What are we looking at here? Why?
The difference is the ones that look like clouds. That's an actual picture of Venus. If you look into a telescope and you look at Venus, you will see that it has an insanely dense atmosphere. Wow. It is covered in clouds. The other pictures, the ones that look more like that reddish thing you were showing, yes, this. I can't see very good. Honestly, from back here with my monitor being that far away, it looks like the sun. But I've seen these reddish.
Very like the sun, dude.
I've seen these reddish pictures before, and these are radar images of the surface. This is an image that they use radar to map the surface, and we've actually landed things. The Russians have actually landed a probe on Venus. People don't know that. It died very quickly. The reason it died very quickly is because of something that we didn't necessarily plan for. We planned for it a little bit, but we didn't plan for it as much as we should have. Number one, the atmosphere is incredibly acidic. So anything you send there will almost immediately just begin to be eaten away at. And then number two, the atmosphere is so dense that it will literally crush a spacecraft. It is about 90 times the atmospheric pressure on Earth. If you stood on Venus, Kev, it would literally feel like you were being crushed by a weight.
I was going to say it'd be like somebody crushing an ant.
Yes, It would be like it would feel like there was like a car on top of you. You would not survive. Just the pressure alone, you would not survive there. And so, that makes exploring Venus a very, very, very tough task. But it's something that we haven't explored. But it is like the planet that honestly we could probably get to most readily. It's the next door neighbor. It's not so very far away, and we haven't done much exploration of it. And it's because it's almost like Pluto in the sense that we've given up hope that it's interesting, which I think is a failure of our curiosity. We gave up on Pluto for the longest time. We figured it was boring. We figured nothing was happening. I already mentioned one of the most geologically active places we've looked at. Now Venus, I think we've given up on it. We assume that it's just this barren, scorching hot wasteland with nothing interesting going on. I would love to see us explore Venus more. There, Carl Sagan in his history of literature, has proposed many ideas for terraforming Venus, for populating the clouds of Venus with different microbes that would turn some of the volatile chemicals into more friendly human chemicals like oxygen. And this has been an idea that's been floated around a lot, is turning Venus back into the sister planet that it probably once was to Earth. We haven't explored it much. I would love to explore it more.
Yeah, absolutely. One place we've spoke about it before, but I would get excited if we were, really serious about getting to Europa, getting up there, because again, we've talked about the potential for life in the oceans up there beneath the ice. I think that would really excite me if we could really concentrate on that. And I know it's a lot further away than Venus, but I think the potential, personally, I mean, you would know more about this than me, but I think that could almost be like a gold mine of information there.
Yes, I was a little bit bummed out when I heard that the next big mission is Titan. Now, of course, that's going to be really interesting, and I'm looking forward to it. But man, I wanted it to be Europa.
Yeah.
I wanted us to go to Europa. I don't think we have faith in our technology to be able to drill through the ice, though. I don't think that anyone in NASA or any of the other space agencies has really firm belief in their ability to literally plummet a spacecraft into the planet and then drill its way through ice that we don't necessarily know how thick it is.
And look,
because
if we go to Antarctica, I mean, look how long it took. I think Russia were the ones that got through into Lake Vostok, but that wasn't exactly the easiest of things to do. And that was with people there manning the equipment and time after time. You're talking, like you say, a one-off shot at doing this. So far away, billions of dollars put into it. Maybe it was just too much of a risk, man.
Yes, it is. It is. I am in the business of taking risks, but unfortunately, NASA's budget has been constrained so much that you almost have to be careful about the risks you take. You don't want to waste 10 years worth of funding to explore something that doesn't bear fruit. So I understand the decision to shy away from Europa for now, but we will be there in my lifetime. I believe that we will be there in my lifetime, and I cannot wait for that time. And especially now with NASA getting hopefully more involved in the science and less involved in the aerospace, we will be getting there soon.
My only kind of worry, and I don't like to get political, but when we're talking NASA, we have to talk about the funding as well. And with the invention or the creation of this new Space Force, or they just changed it to Space Corps, I hope we don't see some of the money that used to go to NASA being cut even further for the Space Force, because I want to see more of the scientific research as opposed to Star Wars style weapons in near Earth orbit,
Yes, I'm pretty confident in saying that the Space Force funding will probably come from the Department of Defense, which I guess just has an unlimited amount of money. I mean, at this point, it's essentially just an infinite amount of money. They don't necessarily even have a cap because they probably have so many, like blank boxes, things that you don't know they're doing, that they could really just spend money on anything they wanted to spend it on. But I really do hope that NASA does not, and the other scientific agencies in the United States and abroad don't suffer funding constraints due to that. Because NASA already, if you live in the United States and you pay taxes, about half of a single penny per dollar that you pay goes to NASA. I mean, a very small chunk. And if you look back in time, in our most fruitful years during the Apollo program, you were siphoning several percent of the taxes you pay would go to NASA. And now we're talking about less than 1%. And I think it's a failure. It's a failure of ours to understand the importance that science has in the world, in the community that we live in. Science is the thing that will push us forward. No matter how much some of these people out here like to deny the effects of science. I got in an argument with a flat earther on Twitter the other day. They just deny the impact that science has had in their life. Wouldn't you have it, they're also an astrologist. I guess that's how it works. They just deny it. They outright deny it. But so many of the things that we use today were invented sort of accidentally or not even for the purpose of profit inside of scientific laboratories. One of the interesting ones that's talked about a lot is the electric screw gun, the electric screwdriver, the handheld drill. All of that was developed during the Apollo days, because we needed a battery pack, because we couldn't plug in power tools when we went off into interplanetary space. When we went to the moon, we couldn't plug stuff in. So we had to invent ways to carry power, and we literally invented what is now become the modern day battery pack, all to try to power what is now the modern day screw gun, this modern day powered screwdriver.
That's pretty cool. And, just thinking back to that whole NASA and Apollo time, I mean, it's quite hard to wrap your head around the fact that if we look at all of technology from 50 years ago and how far it's come in those 50 years, yet the most important scientific mission of its time, and it's stagnated. We're still kind of waiting to go back to the moon. That's so frustrating. So
Yes.
frustrating, dude.
And it has everything to do with money. It has every single thing to do with money. That's it. It has to do with politics and money. I talked to the person that I consider, Dr. David Fisher, to be the most intelligent person, the most knowledgeable historian on this particular topic, on why we stopped going to the moon. The man literally has a collection of spaceflight memorabilia, of original spaceflight documentation. He's met something like 90% of astronauts he's interviewed and talked to and collected stuff from. And he told me that if the government was willing to fund our return to the moon, Project Artemis, if they were willing to give it the money that it required, essentially fund it the way the Department of Defense is funded, then we could get to the moon, this year if we wanted to. But unfortunately, no one wants to invest that sort of money into the space program anymore. And so we go slow. We go very slow. And then politics come in, and presidents don't want to go back to the moon. And then the next president does want to go back to the moon. And then the next president says, no, I don't want to go back to the moon. And, Bush wanted to go to the moon. Obama canceled that. He wanted to go to Mars. Now Donald Trump is in office. He canceled the Mars. He wants to go to the moon instead. And you have this constant political flip-flopping where every candidate wants to leave their mark on the space program, and you don't get anything done. And that's why I look at China and I'm envious, because China is a place where, they don't do many things right, we'll say. They don't do a lot of stuff great. There's a lot of political problems involving China right now. But one thing that they have done right over the past decade is their space program. They set out clear goals that they plan to accomplish efficiently and over time, and they've actually stuck to their guns on that. They said, we're going to go to the moon, then we're going to do X, then we're going to do Y, then we're going to do Z. And they've followed through on that timeline, followed through on the funding, and they've actually gotten results, which is why you see the success of certain missions like these Chang'e missions that you've seen China doing. They're really, they should be an ally in our space program. But again, politics keeps us from working together.
No, you're so right. Imagine, we see it all the time in science. CERN is the one place I usually point people to give an example of how, borders are unimportant when minds come together. And the scientific kind of community, all these political divisions that may or may not exist in reality, they should be put to one side. And we should have our collective thinking power put together for the sake of humanity, And Project Artemis, something you mentioned there about going back to the moon, find this interesting because I was telling you, read a book or listened to a book. I love these audio books because I'm a really slow reader, Brendan. But it was called Artemis, and it was by Andy Weir, and he was the guy that done The Martian. And then months after I'd listened to that book, here are NASA announcing Project Artemis. And for people out there, it says Artemis was the twin sister of Apollo and goddess of the moon in Greek mythology. Now she personifies our path to the moon as the name of the NASA's program to return astronauts to the lunar surface by 2024, including the first woman and the next man. When they land, our American astronauts will set foot where no human has ever been before, the moon's south pole. So yeah, that's this Project Artemis. Give us your thoughts on Artemis, Brendan.
I'm really excited for us to just do something. That's where I stand on Project Artemis. I'm really excited that in the next 5 years we will actually achieve something. For once, we will get humans off into space again, which is realistically all I ask for. I ask for progress, and it has, been painful to watch throughout my life. Very little progress happen in the way of human spaceflight. There hasn't been much happening. And so I'm excited to get down that road again. And they recently came out and published what they expect it to cost, the additional money that NASA will need in order to get us there. They published $20 to $30 billion. They will need additional funding, 20 to 30 billion to get us there by 2024. And I think that this might very well be the thing that kickstarts funding in NASA again, because Donald Trump wants to get to the moon by the time he is done being president. He's assuming that he will be elected for a second time. Maybe he will be elected for a second time. This isn't a political show. I don't care about that. But if he does get elected a second time, he wants to get us to the moon before he's done. That is why 2024 was picked, for no other reason than that. He wants to be the person to get us back to the moon. It is very important to him. Of course, he's the type of person that he wants to have his name associated with everything possible.
Yeah, that would be like his legacy, I'd rather him have that as his legacy as opposed to some kind of confrontation with Iran that was looking likely lately,
Yes, I agree. I would love to see. I don't care who does it.
Same here.
I don't care
dude.
if it's
Same.
Donald. I don't care if it's someone else.
You're the same as me. I mean, we're two of the most apolitical dudes speaking here right now. And I love that about you, because we shouldn't let that get in the way of the stuff we talk about here.
I agree. I agree 100%. I think, and you can look at the history of American spaceflight, and you can see politics all along the way. Yeah. Politics, and it's kept us from progress.
Absolutely. Now, you were talking about the money required. Okay, now, I'm probably springing this on you. I sent you a link there, but I've got a novel way for NASA or any other budding space kind of industry company out there to get the money they need. And this is a story that was doing the rounds last week. This article I've got here is from yesterday, the 30th of June, but it's talking about this asteroid that they say is worth quintillions. Now, I don't know if this is real or whatever, Brendan, but I've seen a few stories about this. I've seen people posting about it over on social media as well. And again, just because you see it on social media doesn't mean I believe it. But something like this, there's a potential for getting money. Okay, it's another space mission, probably one that's maybe a bit beyond us at this point. That's a good source of cash right there, right?
Yes, this is one of the interesting things about asteroid mining in the future. Now here, my wife is an economist, and so she might appreciate this insight. One of the things that isn't taken into account when people write articles like this is that if you go to, do they say what minerals and metals that they'll be finding?
Well, I think it was, here we go. It says here, all you have to do is figure out where to go in space and mine 16 Psyche, that's the name of it, 16 Psyche, an asteroid made of gold and other metals like iron and nickel. But I would imagine if you inserted that much gold into the market, it's going to come down anyway, right?
Exactly. If you bring home an asteroid of gold, no one's going to want gold. It doesn't mean anything anymore. People will be making silverware out of it.
It says every person on Earth would get around $93 billion worth of this gold.
Okay, good. Make a chair out of it. Make a lamp out of it. It doesn't mean anything. Wipe your shoes on it. It's meaningless. The point of rare minerals is that they're rare. If you take away their rarity, they don't mean anything. So yeah, this stuff is interesting. The only way I could foresee something like this happening, and also simultaneously being very dangerous, is if someone has a monopoly on it. Is if there's only one aerospace company that can go out and mine asteroids.
Well, then you have one company I know of, and they're quite tied in. Not tied in, but they associate with SpaceX. It's a company called Planetary Resources, and that's their whole business model, going and mining the moon and potentially asteroids as well.
Yes, and it will happen. It will happen in our lifetime. It certainly will happen. I think I'd like to see. Man, it's going to be tough. Essentially we're going into an interesting place, Kev. We're going into a place never seen before. A place where we're literally expanding our economy into the solar system. No, and I think that is really exciting.
Big time. This is the sci-fi future I honestly thought we would be living by the time we got to the year 2000, when I was a young whippersnapper looking up at the sky, But we're slowly getting there. Now, this might sound like a bit of a bizarre question. I might be entirely off the mark. But on the weekend stream, we were talking about Bob Lazar, and that goes into Area 51. And
Hmm.
part of his story was this element 115. Now, at the time, nobody had ever heard of this and they thought it was all bunk. But then, long story short, Russians were able to reproduce, or they found some of this element 115. Now, I was going to ask you, with missions to, say, Venus or any other planet or moon that has a different gravitational pull and push on the planet than we experience here, probably asking you to purely speculate here, but is there any potential for our periodic table to be added to because different elements form under these different conditions? Would we even know how to test for such things?
Hmm. This is a great question, and let me ask you this first: what is what does the phrase heavier element mean? Like at an atomic level, do you have an idea of what makes a element heavier than another element?
Well, will it have extra protons, maybe? No?
Yeah, sure. Actually, yeah, it's essentially, more atomic nuclei,
Yeah.
protons, neutrons,
Yeah.
electrons, etc. The problem with packing many, many neutrons and protons and electrons close to one another is the electromagnetic force becomes too extreme, and it tries to push those things apart. And the nuclear force can no longer hold those nuclei together, and so they tend to not last very long. Like element 115 you're mentioning,
Yeah.
they create that in a lab. It might have like a half life of
Exactly. Yes,
milliseconds.
minuscule. It's
Yeah,
irrelevant. Yeah.
some irrelevant number of time. Yeah, if I know that Bob Lazar talks a lot about somehow finding a way to keep these elements stable, and I don't know. I'm not an atomic physicist. I am not sure that we have a way to keep elements like that stable. I know that sometimes we can keep atoms stable by supercooling them. That's one of the methods we use. But you have a sort of a lower limit on that. You can only make things so cold. You hit absolute zero. Atomic nuclei stops moving. But unfortunately, you're never going to hit absolute zero. You're just going to put more and more and more. It's like reaching the speed of light, Kev. You're going to put more and more and more and more energy into it, and you're never really going to achieve the result. So these are like
Dude,
technologies
hold
of
that thought.
tomorrow.
We've hit the speed of light. That's another segment done already. Yes, Kev Baker show at light speed, definitely. Getting spaced out with Brendan Drachler. Brendan, before we go, let people know of your massive digital footprint, where they can find your show, brother.
Yes, thestateoftheuniverse.com, and it's available everywhere. Everywhere that you watch podcasts, it should be available. If it's not available there, it probably means you're watching podcasts on a very bad platform. So,
I've heard you can even get your podcast on Zeta Reticuli. Bob
yeah,
Lazar told me, dude.
yeah, maybe it's available there. Maybe they listen to it. I hope they like it.
You
Yeah.
never know. But all joking aside, we were discussing Lazar during the break, and he's really been in my consciousness more recently since he appeared on the Joe Rogan show. It's a story from time to time I've looked at and I've come away from, and I was saying to you during the break, highly controversial character, but for me, I can't find the reason why he would make all of this up. And not only that, he doesn't appear to be the sort of character that thrives with the attention, the spotlight being on him. And that being said, though, at the same time, did he really work on these top secret government programs? Look what's happened to Chelsea Manning. Look at Edward Snowden, real whistleblowers who have exposed some real stuff. I mean, if you're exposing technology that comes from another world, why has he not been thrown in jail? So, I mean, I'm very open to the Lazar discussion from either side. What do you make of him, Brendan?
I am very interested. I had somehow like missed the Bob Lazar. Maybe it was maybe at its peak popularity before I was a competent, grown human
When
being.
were you born, dude?
1995.
95. See, just a whippersnapper, man.
I know.
Yeah.
Yeah. And still 2019 seems surreal to me. But I missed it. But man, it's an interest, and I agree with you that it's odd that he doesn't seem to be making money off of it, at least not in the public eye, right? There's no clear connection between him and he's not like a social media guy. He's not like a Patreon dude. he's not being sponsored by anyone that anyone knows
At the
of.
time when he came out, he didn't go on like the circuit, like shows like this,
Hmm.
trying to sell books. There was none of that kind of fanfare. He kind
Right.
of told his
So
story and then just wanted to sink away again.
yeah, so the only possible reason other than he's telling the truth is that he's crazy. It's just that he might honestly believe the things he's saying and they might actually be false. And I'm not saying they are, and I'm not saying he is, but I'm just saying like that's one of the few possibilities that you can come up with, because you can tell if someone, it's like OJ Simpson getting on Twitter recently. Like, he's out to make a few dollars off the fact that he murdered someone and got away with it. And you can see through that. You can tell it's there. Um, but with him, with Bob Lazar, I don't get that impression. I don't get the impression that he's trying to make money off of it, or that he's trying to get fame or popularity out of it. Because even, you mentioned the Joe Rogan podcast. I've only watched about half of that episode. He seems very awkward. He
Yeah.
seems like he's not comfortable with the overwhelming viewership that he's being seen on,
No,
and you
I
can even
agree
tell,
with you.
like, at certain points he's a little afraid that Joe, the interviewer, is going to grill him, that he's going to, like, really start laying in on him, and you can tell there's a little bit of nervousness there.
And he's
And
had
that
the documentary made recently, and he was on with the director of that.
Yep.
And they had a conversation during the filming of the documentary, and they'd gone right out into the back garden because Bob was worried about the fact they might have been getting listened to anyway. And I think it's Jeremy Corbell, I think his name is. Apologise if I've got his name wrong, but the director,
I think that's right.
who's filming the actual scene, he takes his phone, he takes Bob's phone, and he puts them away, well away
Mm-hmm.
from where they are, and they're talking about element 115, this element that may or may not exist. Now, the next day, his property got raided by more alphabet agencies than he could even remember. And they said they were there because he works for it's like almost a science kit company now. They make science toys and stuff like that.
Mm-hmm.
But somebody had allegedly put in an order for the kind of components and materials you would need to put together something that goes bang. So that was their excuse for being there. But you were talking about like just not hundreds, but lined up vehicles, SUVs with all these different agencies going through everything in his property. Now, he thinks that the reason they turned up the day after they had that conversation was because, hypothetically, he was talking about maybe the fact that he could have sneaked some of this element out of Area 51. So he thinks they were there looking for that. Now, why all this kind of scrutiny from the feds? Why the kind of attempts to erases history if the guy hasn't got a story to tell? It's just that there's so much weirdness attached to it that it makes me think, some of it might be true.
Yeah, I am. Here's one of the things that I find interesting about people's perception of science in relation to this. One of the things that I'm always skeptical about when it comes to flat Earth or this scenario with Bob Lazar is that people seem to think the scientific community is more closed than it is. And what I mean by that is, like, you couldn't keep a secret in this field. You really couldn't keep a secret. You can't. You're not keeping one. If there is a secret in the scientific community, you're going to have a real tough time keeping it, especially for 50 years. That's going to be a secret that eventually gets out. So, like, my biggest red flag is, how is it that no one else has come out about this? How is it that no one else has said anything? I mean, you would be if you're a government and you really want to, like, back engineer some alien technology that you have. Why are you not reaching out to the smartest people alive? And I'm telling you right now, with full confidence, that if you went out and got the smartest people alive, their peers would notice that they weren't there anymore.
Yeah.
If you went out and you went to Harvard and you recruited some, theoretical physicists to come try to understand your stuff, there's a lot of people in the field that would notice that person missing.
And you see, when you listen to Lazar's story, this is me putting two and two together there, but he was a bit kind of one of these maverick standout kind of students because he had the kind of jet propelled motorbike, literally a jet engine, and he was constructing a particle accelerator in the master bedroom of his house at aged 15 and things. So he was a bit of a kind of standout character. And I imagine, like you say, that would be the kind of people I would go to. I would want ones that think outside the box, really, really bright buttons in their field, in this case, physics, stuff like that. I would pluck him away in an instant if I was the recruiter. And I think that's what helps to make this, for me anyway, just a bit more believable because he is the kind of guy you would go to.
Yes, I agree. But why is it that other people haven't been recruited? You know, why isn't that the smartest people in the world are mysteriously being recruited to, you know,
because they all work for a secret cabal, Brendan.
Yeah. Well, I don't know. It's like
I'm
in
just
this field,
joking
like
with you, man.
I know. Of course I know, Kev. I don't take you serious like
No,
some
but
other
this is
people
why I like having you on the show because myself included for a long time, very much of the mindset that science was a closed shop, that scientists would just toe the party line to get funding and things. But you've really shown myself and the audience a whole different face to science. The fact you all hang out, you like talking about, the kind of weird stuff that we get into here that excites you, the alien potential, stuff like that. So I'm glad that we're able to do these shows because I hope in some small way it really changes people's perception of the scientific community because I would imagine that scientists like yourself, this is the kind of conversations like we have that yous are having all the time. And the more
Oh
that
yeah.
yeah.
Yeah. People in this community talk about aliens all the time. Of course. They talk about Bob Lazar, they talk about Area 51. Yeah, because the truth is that many people that end up being scientists, they don't come out and say this because maybe they're afraid that they'll be looked down upon. But I'll say it. Most of them, in their early teens or as children or early adulthood, they were interested in this stuff. They were the conspiracy types because that's the same type of mindset that drives you into science, is being curious, is thinking that there's a mystery out there waiting to be solved. And that draws you into things like Area 50. I remember when I was a kid, I would look at, not a kid's not the right word, maybe like 13. I would look at I would bring up Google Maps and I would try to look at Area 51 above. And of course you can't really see anything and nothing's there. But nevertheless, I was real interested in the idea of Area 51. And I think that people get so interested that they begin wanting to believe someone like Bob Lazar. And I'm not even saying that I'm not coming out and saying that he's lying or that it's bullshit or anything like that because I haven't indulged myself enough in it to even form an opinion. I have to. I didn't watch the documentary. I would like to watch the documentary, and I'll get around to it one day. It's in my list on Netflix with 70 million other things.
Oh, tell me about it.
So yeah, maybe one day, we'll get around to watching that. I'll try to watch it before I come on next time. Then I'll have a formed opinion. But so many people want to believe. They want to believe that aliens have come here and visited. But one of the things we talked about on the break, Kev, is why did they go to the government? How did the government get all of the alien technology? Why isn't there some random dude in Kentucky who finds one of these anti-gravity orbs or something? And you're not going to be able to keep that a secret. That is news, right? You think if you think that somehow the government could get that under wraps, then you don't understand the power of modern day technology, especially when it comes to the way information spreads on the internet. That would take like wildfire. And news agencies would report on it.
Nobody would believe it anyway.
That's very possible, yeah.
The knee-jerk reaction to anything now is, it must be fake. And, the fact we spoke about NASA tonight, that's already flicked a switch in many people's heads, so these two must be fake,
Yeah, it's very true. It's one of the problems, of course, with the internet is the misinformation and trying to juggle misinformation from
We've got
real
so
information.
much information at our fingertips. We should all be boffins. We should be absolutely reveling in the information we have. But it's had an adverse effect where attention spans are going backwards, our memories are failing us. It's crazy. Like I say, it's like an informational paradox, dude.
Yeah, but there's also some hidden benefits to it. Like when I was a kid and I was in school, and maybe you realize this with your son, Kev, we went through a real tough time in the late 90s and early 2000s with kids not reading. They stopped. They threw the books away. They didn't want to deal with the books. The advent of real like TV and video games was starting to take hold, and people didn't care about reading. But we don't have a problem with kids reading anymore. We have a situation now where kids are getting very literate by the fact that they read on their cell phones all day. Even if it's just social media, they're actually reading. And they're reading thousands of words per day, like way more than any generation in the past has read. And it's what, so that there's these side effects that are also like really, really good for society. And that's one of them. Now, fighting misinformation is a separate problem. Sometimes I get wrapped up into trying to like convince people that their flat earth ideas are stupid. And I know I should just leave it go and I should give up. But man, sometimes I put too much effort into it.
Yeah, the way I kind of, I used to think that way, but then I just say to people, no matter what shape you think it is, when you get up in the morning and you open your curtains, still got the same bills to pay. We've still got the same problems. We've still got the same jobs to go to. And, whatever shape it is. I think we're in a hologram or a simulation, dude. So really, does it matter what shape it is? To me, it's all code anyway, right?
Yeah. We might be in a hologram. We might be in a simulation.
It seems to be getting more and more popular over time.
Yes. Man, it's such a... this is one of the topics that just boggles the brain.
No wonder you're kind of rubbing your forehead, man. This is the stuff that gets the neurons pulsating,
Yes, just trying to understand, because the thought of being in a simulation is scary. That might be the most scary idea of them all? Because if you're in a simulation, presumably someone can shut you off. Just, all right, we're done with you. We've simulated enough. Shut it down, and then gone, just like that. Imagine you're gone. You're dead. See ya. You never meant anything anyway. You were just a test. You were a sociological. I've heard people say this, that if we are a simulation, what we are, Kev, is literally sociologists who've learned to experiment, who've learned to conduct real experiments. And they do things like create democracies and see how they evolve over time, or create, situations like World War II and see how they evolve. I've heard this argument.
You think with our technology, people. I mean, it's getting better and better. That's the whole thing that leads to the simulation theory in the first place, right? Because we're on the verge of creating simulations like that. We could literally play out something like we've seen here, albeit in code on a computer, but you could factor in, you could put parameters in there, set them up, give it some kind of framework. Who knows?
I would say we're way further ahead than we were 50 years ago, but we are nowhere near being able to simulate a universe, like a real universe.
Even if we ever did get to that point, though, that opens the can of worms of whether we ourselves are being simulated even more.
Yes.
Yeah.
Of course, it might just be a paradox, The multiverse is actually just living beings that create new universes. It's not the universe creating more universes.
Damn, you melted my head there with one sentence, man.
Maybe that's what the multiverse is. Well, we just live long enough to create a simulation of a new universe, and then that universe goes on to create more universes, and you have a giant web of multiverses.
Are you a multiverse kind of line of thinking when it comes to quantum mechanics, then?
I don't know enough about I think that everyone I'll say this about the people in the world of quantum mechanics. You do not do a good enough job explaining what it is that you do.
Well, I would be worried, because if you said to me, I've got a pretty good understanding of quantum mechanics, my little voice in my head would be saying, nah, he's got to be lying, because nobody understands quantum mechanics.
Yes, there are some people who they understand it, but I listen to people give talks, people really ingrained in the field, like superstars in the field that of course no one outside would ever hear of because they don't do this sort of talk.
That's what we were talking about, right? We were talking about it. You've experienced this as well. It's really hard to get quantum scientists to come and talk about their shtick,
It's very hard, and I don't know what it is. I don't know if it's daunting to talk about this topic. Like if it's daunting to try to be like, oh, I have to explain quantum. Oh, how do I explain the double slit experiment? How do I, that's
probably coming on and speaking to me about it would be akin to speaking to the cat.
Yeah, that might very well be the other thing. They're like, no one's gonna get it anyway. Why even bother? No, Kev's an idiot. He's not gonna understand. Yeah, Maybe that's what they say.
He's
I don't know.
a power of Schrodinger's cat. I'd rather speak to Schrodinger's cat than Baker. You know what I mean?
Yeah.
But I don't know. I often wonder if we have got, this kind of many worlds theory, as they call it, multi-dimensional. It's It's mind-boggling. We can't even conceptualize the size of our own vast universe, and now we're starting to throw multiverses out there.
Yeah, it's man, I whenever I think about the universe and the size of the, I often think about like the end of the universe. What happens at the end? When's it end? Does the universe continue expanding
I used to
forever?
think maybe the end was the beginning, because it might end in a bang. And they say
A
theoretically ours
crunch?
started in a bang. Yeah.
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 So if it starts with a bang, there's a cosmological models that assume a big crunch that eventually the expansion will slow down and then literally close on itself. That doesn't seem to be likely though, because those sorts of models rely on the fact that the gravitational pull of the matter will overcome the expansion rate of the dark energy, which is not happening in our universe. In fact, the exact opposite is happening. The expansion rate of the universe is well exceeding the ability of matter to pull itself together. So in other words, two galaxies are going to expand. They're not going to attract one another and clump.
So
Except for
what's the latest with the dark energy, dark matter? Are we any closer to finding out if it's even a thing?
nope,
No.
nope. We have observational evidence, but we are
What
no
if it's
closer
the
to
effects? It's the effects of the other, other verses upon ours. How about that?
correct. Dark matter, yeah, you're right in calling my bluff on dark matter. Dark matter, we can't necessarily say observational evidence. Maybe observational inference is a better word, because we have some data that suggests that dark matter, not even data that suggests dark matter exists, data that suggests dark matter could solve the problem that we observe. We'll say that.
Yeah, because
But
I mean I've always looked at it as being basically the equation needed something. There was something missing for it all to work. So they came up with this thing. Well, we don't know what it is, so it's dark, and it's dark. We'll call it dark matter, but it's really just to make the equation work. Am I right?
it is sort of to make the equation work. But of course, you do have real observational evidence that something funky is going on.
Yeah,
You do see stars that are for some reason moving fast but not escaping the gravitational pull
got you.
of the Milky Way galaxy, or galaxies moving too fast but somehow not getting ejected from a cluster. That problem, you're right in saying that problem can be solved by adding dark energy literally to your model or to your math. But it's either that or our understanding of gravity is incorrect, and there's people working
Nah.
on that front too, and saying that we should come up with a new formulation of gravity. General relativity works, we've already shown that, but Newtonian gravity is not a good way to look at a galaxy, and instead we should do modified Newtonian gravity.
See,
And there's a
I'm
lot of
still
research going into that.
I'm still in the whole electromagnetism camp. I think that's a kind of stronger force that we should be looking into more. And people say you don't believe in gravity, Kev. Obviously, I believe in the thing that we're told is gravity makes things come back down to earth. Not denying that, but like you say, I think we need to refine our knowledge on it, the process of what's actually happening, as opposed to just the name gravity.
Yes, it's one of the fundamentally interesting things about gravity is that we still don't quite understand how the force is exchanged. What makes when you drop? It's easy to say that when you drop a bottle of water, it falls to the ground, and that's due to gravity. But why? Like from a
Exactly.
subatomic level, why?
Yeah.
From a quantum mechanical level, why? There has to be an exchange of some force there, and it's often been attributed to a subatomic particle called the graviton. But we have not yet detected the graviton
And
in
and
our
we,
particle
and we
accelerators.
found that gravity's a wave anyway with the LIGO, right?
Yes, we found that there can be ripples in the very fabric of space-time. Yes, and that when you can literally emit gravitational radiation
You
when you have
see,
two
this takes us
large
back.
objects
This
merging.
takes us back to Lazar, because this is exactly what he was saying. He's saying we've got no understanding of how this whole gravity thing works. Yet I'm sitting in a laboratory and I'm watching something that's manipulating, producing, and harnessing the power of gravity. He's like, this was totally alien technology to me. I mean, That's why it was so exciting, you know?
Yes, I actually have a real gripe with that aspect of the interview that
Oh,
he did on
do
Joe
tell.
Rogan's
Oh, do
podcast.
tell.
His what the producer was Jeremy Corbell
Yeah,
maybe.
something like that, yeah.
They made a jump. They made a jump between saying this object has anti-gravity or it manipulates gravity in some way that we don't understand. And then he said, and look, we've already shown that gravity propagates as a wave. Those two things, when you break down that statement, those two things have nothing to do with one another. You're just making two statements about gravity. Those two things don't have anything to do with one another. When I listen to certain interviews, I go, oh no, he's not making that jump, is he? Because they don't have anything to do with one another. What does the production of a gravitational wave have anything to do with some anti-gravitational device? I mean, when you actually break that down, what do the two have anything to do with one another? I didn't follow the logic. I think that sometimes people get buzzwords in their head and they just want to throw them out. And I think that was one of those cases. And he knew that his target audience, Joe Rogan at the time, wouldn't have been like, wait a minute, gravitational waves, what does that have to do with what you're talking about? He knew that Joe would be like, whoa, there's gravitational waves in the fabric of space-time? And sort of just immediately take away from the conversation. And I'm not saying Joe's a bad interviewer. He's just not an expert. And I think that the Jeremy used that fact to try to make something out of nothing.
Yeah, because like you're saying, I mean, the gravitational waves, as much as I contest gravity, right? I mean, that's produced by, I think it was like two black holes merging, they said at one point, and that gives off the waves and things. And the technology that Lazar's talking about is this element 115 that seems to be able to generate gravity, even though it's got a tiny mass. So
yeah, they're not related in any way.
No, they're not. No, they're not. No.
Yeah,
very good observation, young man.
There are buzzwords that set my brain off, and gravitational waves is one of them. When I hear gravitational waves, all of a sudden my interest, I might have been paying attention at 50%. All of a sudden now I'm at 100%.
But
and I'm listening.
Before you go, how's your work coming along? Because you are the black hole detective. How's it coming along, man?
Oh, we're at a point now, Kev, where maybe in a year I can come on and not talk to you about the goings on in the community of astrophysics, but actually talk to you about my work, because we're at a point now, Kev, where maybe in a year we will be able to simulate binary neutron stars merging and producing the very gravitational waves that we just talked about, and also forming a black hole. And so hopefully I can come on and we can discuss that in a year.
Oh, absolutely. Before or after you get your Nobel Prize?
That will be well before.
We'll get you and Dr. Brian Keating on, right? That'll be a good show.
Unless I discover some magical object in the next year.
You never
Maybe
know.
anti-gravity balls or something.
You might disprove black holes. You might come up with something entirely new. Who knows?
I don't know. The Event Horizon Telescope has me trumped there.
Yeah.
I think they already proved the existence of black holes. But
I think that ship's already sailed, dude. But this has been brilliant. I love geeking out with you, man. And can't wait to speak to you again next month. Your website again one more time before you go.
thestateoftheuniverse.com. Check us out. Subscribe on YouTube. Rate it on iTunes. Check it out wherever it's available. I'd love to have you.
Lucky will be coming up after the break, and I'll be back tomorrow with Dr. David Warmflash. We are going to the moon tomorrow, folks. So wherever you are, make it TFR and Denny touch that dial.